Welcome back to NASA Edge.
An inside and outside look
at all things NASA.
For part 2 of our coverage of the ELaNa II GEMSAT mission.
Yes, over the next 30 or 40 minutes, we're going to actually look at the GEMSAT deployment of the CubeSats. And coming on the show, we'll have students from all of the schools that were, not all of the schools, but some of the schools that were represented here with the CubeSats this evening.
And if you're wondering where special co-host Tiffany Nail is at this moment, she's out looking for razors because she thinks that I'm going to shave before the end of the show. But I can tell you that this little leprechaun is not going to fall for any of those pranks. I worked hard to grow this beard, and it is firmly ensconced on my face.
Well, I just want to let everyone know it is 2 a.m. Pacific Standard Time. For those of you on the East Coast back home at Langley, you're just waking up to go to work. And
good morning.
And our friends in England are probably having lunch, so it's been a long night, but we're having a lot of fun for this deployment. And before in the last segment when we saw the launch, Franklin had a chance to go out to set up for a long exposure shot of the launch. And Franklin, I think we have one of your shots that you took.
Oh, yeah, you know.
There you go.
Yeah, so just a short shot that I had. I actually had the exposure set for about 30 seconds, and being behind the hill there, the rocket actually stayed on the pad for a while, and I just probably got about 10 seconds after the rocket cleared the hill, but that's the shot from our vantage point here at Vandenberg.
And I got to tell you, it's a great picture. And in your defense, I mean, you'd not seen a rocket launch from Vandenberg before, so you were really kind of playing it by ear, and you did a great job.
Yeah, thank you. I appreciate it. Yeah.
Well, I tell you what, this is going to be a great excitement for the next 30 minutes because in the first part of the show, we talked about the students, we talked about the work that they did, at their respective universities. We highlighted Medgar Evers College in our first segment, but we have representatives. We have not only students, but we have faculty here that we'll be talking to, and sort of to share their feelings of what the launch was like, and also hopefully that the deployment goes well this evening. Yeah,
and that's a good point, Chris, because we actually are going to watch the deployment take place. By using the satellite tracking kit, we're going to see in animation what is actually happening in space. So all of the students are going to get to see their CubeSat deploy in animation and kind of real time in conjunction with what's happening in space.
You want to recap, Franklin?
Yeah, but if you were just joining us right now for the second part of our program and did not see the launch tonight, we're going to take an opportunity right now to look at the launch that took place almost 3 hours ago.
Well, we were
here.
Much better rested.
Yes, here at Vandenberg Air Force Base.
9, 8, 7, 6, 5, 4, 3, 2. Well, you have RD-180 ignition and liftoff of the United Launch Alliance Atlas V rocket carrying the NROL-39 mission for the National Reconnaissance Office.
180 engine operation looks very good. Booster PU is in control.
You are hearing the voice of Marty Malinowski providing launch vehicle.
What was most fascinating about seeing the launch from our vantage point was at other launches we seemed to see either the shuttle or the rocket kind of move away. This sort of seemed to go straight up from where we were. It was kind of a unique perspective that I'd never seen before at a launch.
I think it was the closest too.
Yeah.
And you
some
really
of the
felt
workers
it.
are saying that we were about a mile out, from the launch pad, which we're usually used to 2-3 miles for normal launches on the East Coast.
Yeah, for Laddie, our launch that we did at Wallops in September, it made that arc, and I sat there and I watched it, and it just went straight up in the air, and it just kept going, and it's just different to see. It's exciting actually to see the different launches and the way that the rockets react after they get off the pad.
And that's when I was talking to some of the folks that were outside. Is that when you were taking the long exposure, I said to myself, geez, that's going straight up. It's not really going at it. Is he going to get the entire shot? So,
yeah, and you could really feel it too. I mean, it's often you feel the shock waves from the sound waves. I don't know. These I seem to feel more than I know. We were closer, but the Atlas V is a very big rocket, heavy lifter. So I didn't quite anticipate it, but boy, you felt it, and I'm sure the kids are going to share a lot of what they experienced as well.
Heard quite a few car alarms going off in the lot.
I did too.
Well, I tell you what, the primary payload for this mission was a success.
Yep.
The NRO had a successful deployment, and so now we're getting ready for the 12 CubeSats that are on board.
Yep.
I believe they're on board 8 P-pods, and NASA is responsible for 2 of the P-pods.
Yep.
And that's what we're going to be focusing on over the next half hour.
Yeah, and it's kind of exciting because these P-pods that launch the satellites, it's kind of a unique construction. It's a very important device. It's actually serves to make CubeSats possible so they can ride. It's not just the launcher. They're on a special platform, and it's all designed to make use of that rocket for CubeSats after, obviously, the primary payload has been successfully deployed.
I think you're going to see when we go to the animation, actually the location of the pods on the rocket itself. If you were to think about any other payload deployment, you would think of, you think about shuttle, you think about the bay doors open up. It's nowhere near that.
It's really not.
It's really at the back of the bus, at the bottom of the rocket, near the where the jets come out. So hey, look, check it out right there. You see the animation, and we will see the deployments coming out very shortly.
Yeah, and when the deployments take place, we actually do kind of get like a picture-in-picture where you're seeing the planet there. You're going to see sort of a close-up of the platform holding the P-pods and actually watching them deploy.
And what we're going to be looking at a little bit later, since there are 8 P-pods on this mission, NASA's responsible for the first P-pod and the 5th P-pod. So we're going to be showing you the first deployment, and then we're going to have to wait a little bit of time before the 5th one is deployed.
Well, Chris, I know that we've talked a lot about the P-pods, but I think we have a representative from Cal Poly who's here to talk about those, Nick Weiser. So let's take a quick break. When we come back, we'll hear from him a little bit about how these P-pods work and how these CubeSats will be deployed.
And we'll actually have a P-pod on the table here.
Awesome.
Mm-hmm. And we're back with Nick from Cal Poly. How you doing, Nick?
Good. How are you guys?
Not too bad. And we actually have the infamous P-pod in front of us, or a sample, of what is actually on the spacecraft right now. And take us kind of through what this P-pod's all about.
So this P-pod is a space-designed, built, tested, and proven glorified jack-in-the-box. So you can fit, as you can see here, this is 3 U's worth of length, and this is 1 U. So this is, the 10 by 10 by 10 centimeters.
So you can fit 3 P-pods in here.
No, you can fit 3 CubeSats.
CubeSat,
right.
3 CubeSats, correct.
Right. And or 1 2U or 2 1.5 U's, so on and so forth. So what happens is we bolt this to the rocket.
Okay.
And when the main payload has deployed and launch services have determined that it's an appropriate time, they'll deploy the CubeSats out of the P-pod.
Now
So for this morning, the 4 CubeSats that are connected to ELaNa, we probably have a variation of it being 1U, 2U, and 3U.
Correct.
Right? Okay.
Now is the P-pod just being used for the NASA CubeSats, or are they being used for all 12 CubeSats?
The P-pod's going to be used for all 12 CubeSats,
Okay.
correct.
And so how's that work then with Cal Poly? So if I'm, let's say for example, if I'm Medgar Evers College, and I have my CUNYSat, did they call you and say, hey, look, do you have? How does that work did they send the satellite to you to put it into the P-pod, or do you send them an example of the P-pod so they can work with it to see that it fits?
Correct. We do have test pods that we'll send out for
Okay.
fit checks and vibrations testing, but it towards the end of the program, or towards the end of the process before integration, typically teams will travel to Cal Poly and do their final vibrations and any vacuum testing they might need to do with us with the flight hardware.
Now, you're not that far away from Vandenberg Air Force Base, so how many launches have you seen that's had a CubeSat on it, or just in general that hasn't?
Let's see. So I've seen 2 launches in the last 2 years
Okay.
out of Vandenberg, and one had P-pods, one of which was CP5, one of Polysat's satellites, but most recently I saw the SpaceX launch in September.
So the launch last night was quite, do you still get a thrill every time you see a launch?
Well, absolutely. I mean, there's nothing like seeing it in person. You know, you can stream it online, but it's never quite the same as feeling the energy hit you.
Actually, it's a good call that you said last night, because that's how long we've been here. You know,
I know. And I have to say, since I'm sitting where Blair sits, I know he said he called himself a leprechaun, but I just want to go on the record that really he's like Grizzly Adams. So I'm just saying. It's really early.
Well, I got to tell you, I mean, this, when we were at Cal Poly looking at the P-pods early in the year, I mean, it's very well constructed. It looks like, it's a very heavy piece of hardware, and it's pretty cool. I can't wait to see it deployed tonight. And
Generations worth of work.
And what we're going to do is we're going to see you later on the show, because you're going to be talking about one of Cal Poly's CubeSats called IPEX.
Absolutely.
But what we're going to do is we're going to go back to the STK animation, check it out, and then we're going to be back with Dave Klumper from Montana State.
We're back here with Dave Klumpar from Montana State University. Dave, you're a P-pod. Your CubeSat's about to deploy shortly. But before we get to that, can you tell us briefly a little bit about Firebird?
Yeah, Franklin. Firebird is actually an acronym. You've heard of 3-letter acronyms. Well, this is an 8-letter acronym. And it stands for Focused Investigations of Relativistic Electron Burst Intensity, Range, and Dynamics. Now, how's that for an acronym?
That's a mouthful.
We've topped NASA on this one.
I thought I was going to have to break that out myself. I'm so glad that you took it for us.
All right. Well, actually,
what does it mean?
Firebird, yeah, okay, let's get down to that. Firebird is actually 2 satellites. They're 1.5U satellites, and we need 2 satellites to do this scientific mission. So in this P-pod, where sometimes you can put 3 satellites, we build ours to be 1.5 times the size of a normal CubeSat, and we put 2 of them then to fill up the P-pod. When this door opens and those satellites pop out, they will be slightly separating in space, in time, in space. And the idea is that with the 2 satellites, we're going to be able to look at relativistic electron microbursts. Now that sounds like a mouthful, doesn't it?
It is, but I tell you, we're about ready not only to see that happen, but we're ready to see
cool.
the deployment. Actually, it looks like on the satellite tracking kit we should be seeing deployment anytime. We're going to leave it on that. Go ahead and you can see it,
All
but
right.
continue to explain it, and we'll see if we can.
Okay, well, we should see in this animation that the two satellites, if it's a good animation, the two satellites come out, and they're slowly going to separate from each other. We keep our fingers crossed that actually happens. And as time goes on, they get a little bit more further and further apart. The concept here is that we're looking at radiation that's coming out of the Van Allen radiation belts. It's called they're called the trapping zones for radiation, but they're actually leaky, and they don't always contain all of the particles that they're supposed to. Now these are relativistic electrons, very energetic charged particles.
And we just look like we saw them.
Did we
deploy.
see it? All right.
There you
Go, Firebird!
There you go. Oh, that's awesome. It's just amazing that right now, while we're down here, that's happening in space. And so Firebird, it looks like, is a go.
Well, we sure hope so. Our team of students is back at Montana State University. We should get our first contact with the spacecraft about an hour and a half from now. For the first hour here, the spacecraft is just sitting there, ticking away, waiting for its clock to expire at 60 minutes. Mm-hmm. At that point in time, it comes alive, its communications antennas deploy, and it starts beeping at us. It starts beaconing down to the ground. 27 minutes after that happens, we get the first pass over Bozeman, Montana.
Well, and that's what I was going to ask you. I know there are ground stations all over, and a lot of people track these, but you actually have a ground station in at Montana State University.
That's right, right on the campus.
Perfect.
And I wanted to point out that that it's really takes a lot of effort for universities to put this together, and it's a multi-university team. Montana State University and the University of New Hampshire. The satellites are funded, the mission is funded by the National Science Foundation. NASA provides the launch for us, and the NRO provided the vehicle. So here we have a case where universities, government, three agencies working together.
Well, I tell you what, it's fantastic, and I know that you guys are going to get good data. Probably, how long did you say? About 45 minutes?
About an hour and 15 minutes.
Hour and 15 minutes. Well, tell you what, let's go back to the animation, and we're going to come back with some other students and get their input. Congratulations to Montana State.
Well, let's hope it's true.
I'm sure it's going to be successful.
We're back with Andy Klesch from Jet Propulsion Laboratory and Sohee Kang from University of Michigan. Sohee, this is your first launch.
Yep.
How exciting is this?
It was really exciting because it was my first launch ever visited, and it also had the first satellite that I worked on, so it's pretty exciting.
And your first satellite is MCube 2.
Mm-hmm.
Tell me a little bit about MCube 2.
So MCube 2 is a technology demonstration for JPL. It's got a FPGA-based processor on it that is our payload, and we're basically providing a bus and a power system to fly it in space.
Excellent. Now, I think, Andy, we have a little history. There was a M-1, and we were you guys were attached. Tell me a little bit about that.
Right, so we launched M-1 just 2 years ago, actually, along with Montana State, who launched E1P Explorer 1 Prime. And unfortunately, there was an anomaly after deployment, and both of our CubeSats ended up sticking together. Now, Montana State felt so bad about this that this time they chose their own P-pod. We're separate from them, and we're looking forward to getting great results from both the spacecraft on M-2.
Excellent. And actually, you still hear from M-1, right?
Absolutely. Both the spacecraft, even though they were docked together, Montana State and Michigan are both reporting great data back. We're still getting telemetry from them, and we hope to continue to hear from them into the future.
So that just points out, even though you have an anomaly, you can have a successful spacecraft.
Absolutely. Failure is something that we account for, and then we move on from.
So let's talk about deployment. That's going to be coming up in a little while. How are you feeling about that?
I'm really excited. I wish, I don't know, we don't really see the results until it deploys and beacons, so
right.
That's like the height of.
But it's a milestone.
exciting.
So
Yep.
you had launch, deployment, and then you're actually going to communicate to the satellite.
Yep.
So 3 things in a row within 24-hour span, right?
Mhm.
That's got to be exciting.
It is
So,
very exciting.
Andy, any last words?
I'm just looking forward to seeing this one go, as well as JPL's other CubeSat you'll hear about in a few minutes on IPEX.
Excellent. All right. Well, I think we're going to go back to STK feed, and next set of college students will come and join us. Nick, thanks for coming back, and we're going to be talking about the CubeSat that you worked on called IPEX. But before we actually get to that, Cal Poly has been working on CubeSats for a long time, and I think this is your 5th or 6th mission up in space?
Correct. This is the 6th one that we've launched. Yes.
And this is a sample of what a CubeSat looks like.
Absolutely. Yeah, so this is the engineering model for CP1, one of our first satellites. And it was, roughly the proof of concept, the first thing we wanted to fly, and we've really progressed our electronics and our whole system bus since then.
Is this an antenna?
Yeah. Yes, it is.
I was just about to ask that same question. What is that sticking out of?
That's our dipole.
Well, tell us about IPEX. What's that all about?
IPEX is an onboard image processing experiment. IPEX is short for Intelligent Payload Experiment. And we've worked with JPL on this project to develop kind of our bus, and it's largely about the processor that we're putting together and taking a lot of pictures. And so that's what the intelligent software is going to be running its processing on, is on the pictures that we take coming out of the P-pod immediately, which should be happening shortly.
Now, I understand for this particular CubeSat, you actually tested it using a balloon back in 2012.
Correct. It went up to about 100,000 feet. We got some very beautiful pictures and tracked it when it came back down.
Interesting.
After parachute.
Now, when are you expecting to communicate to your satellite?
Our first pass is about 5:30 in the morning. We have a very narrow window to talk to it, and we're hoping to hear a very brief blip.
All right.
Now, one of the interesting things that I read about it is the fact that once you're finished with your mission, that the amateurs will have access to it.
Correct. It will be used as a digipeater. Yeah.
What's a digipeater?
You send some thing up to the satellite, and it sends it back down.
And so, how long will that last until the spacecraft comes to the orbits, or?
I just see we had a deployment. Is that correct?
Oh,
Yep.
really?
Yep, we just had a deployment.
Successful deployment of the fifth canister.
Wow, so the 5th canister has deployed its first CubeSat. It looks like we'll be having the next 2 coming here shortly. So what do you think? So
I'm very excited. My team is surely back home, anxiously awaiting the results of our deployment, and IPEX is rapidly taking pictures. There's a lot of our team and our efforts are riding on this mission. So
how long will it be before you actually communicate then?
a couple hours. I think it'll be about 5:30 in the morning is our first chance. So we've got 3 hours.
I also read that it takes about, CubeSat lasts for about 180 days. Does that sound about right?
There are a
Before
lot
it
of-
falls to Earth and then it burns up in the atmosphere.
There are a lot of different parameters that go into that kind of calculation, and orbital parameters, your mass, your drag coefficient. There is a small amount of atmosphere in low Earth orbit, and that's part of what helps the. That's why you have to take into account friction.
Okay.
Well, Nick, thank you so much. Congratulations again on deployment, and hopefully in a couple hours you're going to be hearing the signal for the first time.
Very hopefully.
Okay. We're taking a look at the STK, so we'll be right back.
Well, we're back, but we may have been wrong. We may be about ready to witness the deployment of yours. The launch slipped a little bit, so our schedule may be off. So let's keep on the feed just in case. But we're here with Ernst and Ralph, who we talked to at Medgar Evers. Guys, how's it feel to be about ready to witness your satellite take its first flight?
Blair, the feeling is amazing. Honestly, you heard the saying, hard work pays off. This is a testament to it.
Oh, there it
As you
goes.
can see,
Wow,
it goes
wonderful.
right there.
Oh yeah, on the way.
Seeing this small cube develop into a fully functional satellite is amazing. And I have my teammates here to support me.
Yes.
Seeing my first launch live,
It's great.
It's something I'll cherish for the rest of my life.
It's awesome, and one of the things reasons we're happy to be here is because it's so impressive to see the work that you've done actually come to fruition here on this mission. And Ralph, how does it feel?
Oh, the thing is that it's been a while that we've been working on that mission, try to get it together, and at some point of the time to put it on that rocket. When you see that, it's more like there's something going through your spine. When you see it, boom, it's really happened. It's more like from all the equation, from the theory, and to make it really work. And now we basically gonna get a chance to test whether or not if all our theory is all of the equation that we put on paper is everything gonna basically match, one by one. That's a great opportunity for us.
Well, I tell you, I got to admit, I remember being back at Medgar Evers and you guys talking very enthusiastically about this. But I tell you, I'm really proud of you guys, and it's quite an accomplishment. But as I understand it, the work's really just beginning. When are you guys going to start getting data? What's the next step for you guys as you are now successful sateliteers? Did I just coin a new word? Satelliteer?
Well, you're right. The work, is just started for us. Where hopefully tomorrow we're gonna try to head out to Cal Poly and try to see if we can, get some feedback from our satellite. And as soon as we head back to the school at Medgar Evers in Brooklyn, we're going to, go back to our ground station and see if we can get some feedback as well. And this is just the start of many things to come, and I'm really happy to be a part of this.
Actually, that's an amazing opportunity for us because we already have that on a plan, like from date to date, what's supposed to be the response of our satellite, and that's basically like the next step, and we're gonna work on it. Hopefully, everything should be fine. If for some reason something will go wrong, that will be like maybe like a better opportunity. We will know that where our equation went wrong, and the next time you will get it right on point.
I got a question for you guys, and this is kind of a different kind of question. Now that you've both, designed and built and flown a CubeSat, are you going to try to maybe do more CubeSats? Or are you going to try to do bigger satellites? Because CubeSats are now becoming very popular in their own right across the science and engineering community.
This is actually a stepping stone for us. Learning all of this and putting all of this knowledge together will help us to further our development. If we actually go ahead and pursue a second CUNYSAT, we will definitely make it a lot more complicated, and and basically take it to the next level.
Well, by next level, it earns mean we're gonna have maybe like a better scientific mission on it, because now it's more like we are more like on the learning process.
Sure.
To know that whether or not if our team get the team together, like get to the rhythm of it. But now since we passed that, now the next level will be basically get a better scientific mission, and maybe you never know, get a bigger, move out of the CubeSat, maybe get a real satellite, functioning satellite.
I don't know if you guys out there have noticed that these two students now have a little bit of moxie. They're actually acting like veterans now. I tell you, it's great, it's awesome, and just congratulations to you guys. And now we're going to take a quick break and come back on with some of your fellow students and talk to them as well.
We're here with Bridget and Owen from Medgar's Evers College. And Bridget, a couple weeks ago we were in Brooklyn, and you were preparing to come on out here to Vandenberg Air Force Base to see the launch of ELaNa II and the deployment of the CUNYSAT. Now that it has happened, what's going through your head here?
Oh, everything it's just everything. I'm already ready to start focusing on CUNYSAT 2 as we track CUNYSAT 1, and it's just really fantastic right now. My heart is just pounding a million miles an hour. It was awesome.
And it should be. Owen, we didn't talk to you when we were in Brooklyn, but you're here now. You're on the SAT. You saw your satellite deployed. What's going through your head right now?
Just quite a lot of things. I was the first systems engineer on the project, and it's just amazing to see this project that we started so many years ago just come into fruition, launching, and it's like watching all these ideas, all the hard work of the students just being thrown out there from the Peapod. It was amazing. I can't wait to see the first data coming down from the satellite.
Speaking of data, Bridget, while we were at Medgar Evers, we walked up to your ground station.
Yes.
We were up on the top floor. Tell us a little bit about the first steps you'll go through when you return back to Brooklyn to start collecting data from CUNYSAT.
Oh, we're going to see if we can get a beacon going. We're just going to go right back to school, get in the ground station, and start everything up. Hopefully tomorrow, actually, we're going to go to Cal Poly. They're being very gracious, and we're going to see if we can get some beacons from their ground station.
To actually receive that first bit of data, that first beacon,
it's going to be fantastic. We're going to jump sky high. Mm-hmm. It's going to be completely awesome. And once we know we have that first beacon, then we know we're ready for the second CUNYSAT.
Owen, tell us a little bit about the next steps for you in this program, moving forward with CUNYSAT and moving on toward the CUNYSAT 2.
Well, I know that we have a lot of plans that were on this particular satellite that are just going to be moving forward to the next one, and then the next one, right? So CUNYSAT 2 is going to be bigger, better. Right now, like Ernst said earlier, this is kind of like our stepping stone. So CUNYSAT 2 is going to be flying more science. It's going to be flying more technology. We're hoping to get a lot more effort from a lot of the other institutions in CUNY with it too. So it'll just be bigger, better, badder, and all the more awesome.
Bigger, better. Did Dr. Austin come out with you guys?
Yes, she did. She's actually still waiting for us at the launch pad. We're hoping that the rest of the team is not too cold right now.
Okay.
Yes, she's extremely excited to see this finally take off. We're all extremely proud of each other. The hard work has just been phenomenal.
Well, we were happy to have you all here coming out to Vandenberg Air Force Base, and we had a great time coming to visit with you in Brooklyn, and we look forward to CUNYSAT 2 and more and exciting and better things from Medgar Evers in months and years to come.
Thank you, Frank.
Thank you so much.
Right now we're going to go back to the STK, and we'll be right back in just a moment.
So he came back with me, and then now we've added Devin Hump. They're both from University of Michigan. Guys, your CubeSat's been deployed. How exciting is that?
I mean, it's pretty awesome. This is the first one that I've worked on personally, so it was pretty sweet watching the rocket go up into space. So it's pretty exciting.
And we talked earlier. It's also your first launch too.
It was also my first launch, and I just saw the satellite come out through the STK simulation, so that's really exciting.
That's got to be watching the launch was cool, and now we've just went to double cool, and now the next step, you guys are going to leave from here, and you're going to go where?
We're going to drive 3 hours. We're going to end up at JPL. We're going into their ground station, and we're going to try to hear our satellite about 7 a.m. this morning.
So I'm wondering, do you guys want to like hum the fight song for University of Michigan? You feeling it or what?
Hail to the victors valiant, hail to the conquering heroes, hail, hail to Michigan, the leaders and best.
Hail. Nice! Good job! That's true. Like Blair said, not bad for 2 a.m. because we've all been up. Well, you guys have probably been up, more than 24 hours?
Well, it feels like more like almost 5 a.m. for us. So.
Oh, yeah. That's right. East Coast time, right? Yep. All right. Well, I think we'll go back to STK feed and then be close to wrapping up the show.
Well, what a success. Now we've had deployment of the CubeSats. We had a great launch this evening, and we've wrapped up our, seems like a 24-hour coverage of the mission.
Yes, and I'm still awake. The caffeine has not run out yet. And of course, the enthusiasm of the students really made this possible. Just good work to all the schools, University of Michigan, Medgar Evers, JPL. We had people come up from JPL. We had Montana State University, and of course our old pals from Cal Poly. Quite a group of schools, and just the effort was spectacular. And of course, just hats off to all of them because their satellites have been deployed.
I agree. And also, you managed to still keep your beard.
Yes, and it's going to remain intact until the wife says it's okay to get rid of it.
That's important. I would like to mention, though, our next ELaNa launch is ELaNa 5, and it's going to be launching from Cape Canaveral Air Force Station, and that's going to be on a SpaceX vehicle, and we're looking at sometime in February of next year.
Very good. And we want to thank everybody here at Vandenberg Air Force Base, the NRO, ULA, NASA, LSP, the Launch Services Program Office, for making this live webcast possible. And again, a huge shout out to all the students from the schools, as you mentioned, Montana State with New Hampshire University, Medgar Evers, University of Michigan. It was just a phenomenal experience to actually see their CubeSats deploy.
It's like I mean, a whole new team of satellite makers graduated tonight. It's
Sateliteers.
Sateliteers, yeah. It's a great feeling. Of course, I also have to thank Dr. P for providing the P-pod.
Hey, you know what? I think Nick just took off early, so you may have this for Magnetostar 1.
For future development, that's key. And then also Garrett Scrobot, who I'm sure is still watching from Japan. Wish you could be here and wish you a safe return. These guys have benefited greatly from the ELaNa effort.
Hey, and real quick, I want to thank the communications and the IT team here at Vandenberg. They got us up and running. We had a couple issues when we first arrived, but they got us through, got us on the air, and they made this day possible.
Yes, they did. Although they wanted to see the beard go too, which I don't forgive them for that.
Oh.
And I think that there's only two things left now. One is for the schools to communicate with their satellites, and for everyone to get some sleep.
Yes.
Yeah, and that's a good point because they're actually, we may go to get some sleep, to a man and woman, they all were going back to look to get data.
Right.
I mean, they weren't resting. They're excited to go actually hear from their satellites. I tell you, they got a lot of energy, a lot of enthusiasm, and we wish them well.
Well, thank you for joining us this evening, and we look forward to another live webcast from NASA Edge.
Maybe in February?
Maybe in February. Fingers crossed.
Have a great morning.